Boom, bam. Jumping right back into this one's going to be Physics 2, exam question number 1. I feel like I'd rather do back and forth for physics. Statics hasn't released exam 2. I can really only cover all of exam 1, which I think I did, yeah, just today. So for physics, I have both. So the good news there is I can just go back and forth, which I think might be a little bit more helpful than doing all of 1 than all of 2. If I learn it as a chunk, um, it might be better than, you know, when I get on the test, it won't be so compartmentalized, I guess, in my head that, this stuff was all the way back there, this stuff's all the way right here. I can kind of group it all together and bring all of it, all the knowledge there. I don't know. It's a theory. I don't know. So let's do problem 1 here. This is all about equivalent capacitance. You'll notice here, and especially about series versus parallel. I don't even have my notes pulled up for this, but I can point out that you notice these are very clearly parallel, and that's parallel here. This would then be series. These would then be series. Or I think I might have confused parallel with series. But you know what I mean. These would be in series. These are in parallel. And then this equivalent and this equivalent would be parallel. So, whoops, one's too many. Let me show you what I mean. If I can get back. So to redraw this here, I'm saying that this is going to be the equivalent of, I'm going to draw this kind of like this. And hopefully you catch how I got here. So this is C4, 5, 6. This is C3. And this here is C1, 2. C1 and 2 got combined into one equivalent capacitor. And then C4, 5, and 6 are all parallel like this. So this equals, I guess, just one equivalent here, using the laws of parallel versus series. So from here, we can combine them further and say that this is C1, 2, this is C 3, 4, 5, 6. And then we can finally get to our final C1, 2, 3, 4, 5, 6 equivalent capacitor. And then we have here the plus and the minus, and the voltage is 10 volts. And we can just work all the way backwards from here. So now we're asked to find the equivalent capacitance. Well, let's write down that C1 equals C2 equals C3 equals C4 equals and C5 equals. I think we only have, and C6 equals. This is going to be 2, 2, 10, 4, 5, 6. Okay. Now when we combine 5 and 6, okay, into their C equivalent, C5, 6, that's going to equal, well, they're parallel, so they just add up to 11. And then when we add 4 to C5, 6, This equals 15. Now we're hitting our first series. So when we add 10 to this for the C equivalent, this is 1 over 10 plus 1 over 15 inverse, which in my calculator I'm getting 6. And now 1 and 2 we said were in series. So this is going to be equal to 1 over 2 plus 1 over 2 inverse which is equal to 1. And now these are parallel, so the equivalent capacitance should be 7, not microcoulomb, microfarad. And this is a very sloppy way of doing this, but it's how I got my ideas across this time. I've never done it this way before. So I apologize for that. And so that's A. We've got that. And B is charge on C2. So if we know that this here is equal to 7, right? Now we can say that 10 volts, C equivalent here is just one capacitor, is going to equal 7 microfarad. Well, Q equals CV, right? We have C, we have V, which means we have Q. So Q is going to equal 70 microcoulomb. Okay, so that's B. And now we're gonna have, well, let's split this back up. This is where the power comes from. Now we're gonna have 1, 2, and then the equivalent here, this is gonna be C1, 2. And this here is the equivalent of C 3, 4, 5, 6. See, 3 with 4, 5, 6 is going to be equal to 6. It's going to be 6 microfarad. C1, 2, 1 microfarad. And we know that Q is 70 microcoulombs. But we don't know the voltage here. It's going to be equal to 1 V. Well, let's see. They're in parallel. Voltage is going to be equal to, let's see, we make this V 1 plus 6 equals 70. Divide this by 1 plus 6, which is divided by 7. So V equals 10 still. So that's something. So for Q12, that's going to be equal to 1 times the voltage of 10. So Q12 equals 10. And because this is in series, charge is the same across 1 and 2, so Q2 equals 10. And now it asks, what's the charge in 5? Okay, this is further on down the road. So, similar, we can find Q in 3, 4, 5, 6. Going to be equal to 6 times 10, so that's going to be equal to 60 microcoulombs there. And if that's 60 microcoulombs across 3, 4, 5, 6, that means that C3 equals a charge of 60, and then C4, 5, 6 have a charge of 60. Those have a charge of 60. Then we can say that, well, we can find the voltage. That's what we need to do now here. Voltage here, chart Q60. So we're going to have 60 equals, this one's going to be 4, 5, 6, 4, 15 V. We divide both sides by 15, and V equals 60 divided by 15, which equals 4. So we have a voltage of 4, and in parallel, voltage is the same. So if C5 is 5, and the voltage is 4, then the Q equals 20 microcoulombs. And that's part B, and then that's part C. Extremely hard to follow. I do apologize. But I hope that with some reference that voltage carries over with parallel, and with series, charge carries over, and with parallel, charge adds up, and with series, voltage adds up, and of course how to add the equivalents. The series is inverse and parallel is direct addition. With that knowledge, hopefully that background, this was at least legible, understandable, comprehensible. I do apologize for the abstract nature of this. Not my intention. So, yeah, there's the problem, as I understand it.